the cost of healthcare again today, but this is sort of like part two. We have to think about it from this point of view. Yesterday's lesson, we discussed the idea that that healthcare costs were increasing exponentially, and we ended up with sort of like two models. Okay, we ended up with a model from 2002 to 2006, and when we did the calculations there, we ended up with a growth rate of around about 9.5% per year, right? Then we started with 2007, and I think we went to 2013 maybe. Is that what we did? Yep. And when we did that, we ended up with a growth rate of about 7% per year. So what we decided is that we could come up with sort of like a best case scenario. So here would be a best case scenario for users of healthcare, right? Notice that the starting cost, the cost in 2000, would be $9,029 based on the model from 2007 to 2013, and that the model from 2002 to 2006 gives a y-intercept or a starting amount for the year 2000 of $7,737. So what we could do is we could put those things together into one formula and say, here's our best case scenario. Okay. So the best case in terms of users of healthcare could be that healthcare costs would be $7,737 in the year 2000. This is the year 2000. And then increase by an average of about 7% per year, where X is years since 2000. Right? This is what I'm going to call your best case scenario. If this function rules the costs or tells us what costs are going to be in the future, then this is going to be the best it can be for us. So let's talk about that. Let's compare the cost of healthcare to what salaries are like. Okay, so here is some information from the U.S. Census Bureau, and it shows us the column I'm going to focus on is this column right here. This is the amount of money that people brought home as a median salary. So, for example, if you look at the year 2002, here we are, $41,624. That's the salary that half the households in the country brought home more than that, and half the households in the country brought home less than that. That's what it means to be the median. Okay. You might ask yourself, why do we think about using the median here? For those of you who know something about statistics, the median is non-resistant, right? Undoubtedly, in the United States, I bet the average salary is higher than this, because if you did the average salary, you'd average in those people who make $2 or $5 or $7 million a year. But there's not a lot of those, but it would still pull the average up because they're outliers on the right end of the salary spectrum. So median is a better measure. Okay. This other column next to it, this column that says inflation adjusted, that just, if we're not going to use that for the purposes of our calculations, but this number 55,000 next to the 41,000 is sort of a way of comparing $41,262 in the year 2000 to today's money. So if you were back and living in the year 2000 making $41,000, that'd be like living in the year 2012 and making $55,000. Okay? What's sort of a little alarming about that, if you compare that number to this number, right? Someone making the median salary in the year 2000 was better off than someone making the median salary in the year 2012. Okay? So that's something, that's a different conversation, though. So for the time being, we're going to compare the nominal salaries here in the various years to the cost of healthcare and how it's increasing. So now we need to pick some points. Again, we're going to let X be years since 2000. So let's consider the year 2002 for a minute. Let's consider that. That would correspond to the point 2, 41, 624. 624. I wrote 42, but it should be 624. So there's that coordinate. And then maybe we'll compare that to 2006. So that's going to be 6, comma, 47317. So let's take a look at those two things and come up with something. So 241,624, comma, 6, comma, let's remind ourselves here, 47,317. 47,317. And salaries, too, tend to grow via an exponential function. So we're going to create an exponential function that models what salaries look like for these people during these years. Okay, so we know our equation is going to look like this, a times b to the x. Okay, and so we'll plug points in and see what happens. So we get 47,317 equals ab to the 6th. And then we'll take this one, 41,624 equals ab to the 2nd power. Okay? And we're going to do the familiar trick. We're going to divide these things. And if we do that, the nice thing that happens is the a's cancel for you. B to the 6th divided by b squared is b to the 4th. And then we just have to do 47,317 divided by 41,624. 1.137. All right. So then to solve for that, we're going to say b is equal to 1.137 to the 1/4 power. And the reason we do that is because we want to get rid of that 4 as an exponent, so we raise it to the 1/4 power. We do the same thing on the other side. Okay, and if we do that, we should finally get an answer for b. b is approximately 1.033. Okay, so that's a start. So we can now write our equation like this. Y equals a times 1.033 to the x. And maybe you're noticing already that if you look at this base here, that's our b value, that implies a growth rate of 3.3% in salary. Now, we think back to the other lecture, we know we're kind of in trouble, right? Because even in our best case scenario, health costs was increasing by 7% a year. All right? And in one of the other models, we got something that was 9.5%, almost 10% per year. Here, our salary growth rate for the median salaries is 3.3%. Okay? So this rate is slower than the rate of growth of health insurance. All right, let's finish this off, though. These people are, health salaries are higher. So let's see what we got here. We'll pick the point 2, 41,624. So 41,624 equals a times 1.033 squared. So that means that a equals 41,624 over 1.033 squared. And if we do that, we're going to get about $39,007. Okay. So there we go. Great. So I'm gonna leave it like that. We're gonna say that our equation for salary now, all right, if you want to call or income, we'll call it I for income, is 39,007 times 1.033 to the x. Okay. So what's sort of nice now is that we actually have two functions. We have a function that will tell us salary or income of households from the year 2000 on. And we can compare that, I'm going to say versus the healthcare cost function. I'm going to call it H equals. And what do we have? We had 7737 times 1.07 to the x. Now again, we know that this healthcare cost formula is sort of the best case scenario, right? It's not exactly what really happened. We know that for certain years, from 2002 to 2006, the rate of increase was higher than 7%. And then after that, it was around 7. So, okay. So what I want to do now is I'd like to graph these things and compare them and see what sort of things are going to happen in the future if these trends continue. And that's a big if. I'm going to emphasize the word if here, because it's if everything stays the same. If this base for healthcare doesn't get smaller somehow. If maybe people's salaries don't start to increase at faster rates. Okay, I'm saying let's leave things the way they are and see what happens. All right, so we'll go to our calculator. We'll go to y equals. Okay, we'll clear out whatever's there. This is an 84 we're looking at. Some of you have 89s. On an 89, do diamond F1 to get you to y equals. Okay? So we're going to put that salary in. So 39007 times 1.033 to the x power. Okay? Once you do that, hit enter. You go to y2. And now we're going to put healthcare cost. 7737 times 1.07 to the x power. Okay, we hit enter again. So there we are. We have our two formulas. Now, you could try and graph this right away. You could press Zoom 6 or Zoom Standard and try and graph this, but I think it's advisable to consider what the window should be before we start. All right. So I think a good window might be this. We could talk about window. Remember, x is going to be time, so I'm going to go from 0, which is the year 2000, to x max. I'm just going to go 20 for now, 20 years into the future. That's all we're going to consider. And for the x scale, that's 1. That's reasonable. For y min, none of these numbers are, the lowest number is 7,737. So I make y min 0, as in 0 for cost for healthcare, 0 across, 0 for salary. And for y max, remember, we're starting around 39,000. We knew that it got up into the 40s. Let's make y max, just to be safe, let's make it, say, $90,000. I don't know if that'll be good or not. We'll see. And then for y scale, I think I'm going to go with 10,000. Every 10,000 will be a dash mark on the y-axis. Okay? On the T89, you can hit diamond F2 to take you to window. Diamond F2 takes you to window, and you can type all those things in. All right? Let's press graph and see what happens. So here is salary for the next 20 years. And here comes the healthcare cost for the next 20 years. Okay. All right. You might say, hey, maybe that's not so terrible. I don't know, right? So if we take a look at things on this picture, let's make this picture a little bigger. Okay. And let's take a look at some stuff here. So, for example, if you look at the beginning, right here, here's the y-intercepts. This was 39,007. This was 7737. If we want, we can calculate the following. Percent of income spent on healthcare, right? So we can do this by dividing those in this way, and we get about 20%. Okay? Now, we've mentioned this, that employers generally, if someone's working for a big enough company or has a good job, that employer might pay a portion of this health insurance. So you wouldn't have to pay the whole thing. Okay? Anyway, that's what that is. Now, let's go over here for a minute, because there's more points out here. Has this ratio changed over time? That's what I'm interested in. Let's compare this point to that point. So you can get those points direct from the calculator. We go back to the calculator, and we hit the trace button. On the 84, there is a trace button. On the 89, you could just press F3, which is trace, and type 20, enter. And what you see is that in 20 years from now, that median salary, assuming a 3.3% rate of increase, should be about $74,670. So I could put that here, 20, 74,670. This point down here is going to be 20, something. Let's figure out what healthcare costs then. So on your calculator, you hit the down arrow, okay, and here you go. You get 29,940 basically is what you end up with. 29,940. So I would like to calculate another ratio. Remember, this ratio here was for the year 2000. So this is what should have been happening back in the year 2000. People were spending about 20% of their salary in terms of healthcare costs. So now we're going to look at the year, and 20 years from now, that would be 2020. 2020, according to this model, the percent of income spent on healthcare is going to be 29,940 divided by 74,670. And if we do that, what do we get? 40%? About 40%. Now, that is a very high number. See, it's sort of natural. Most of your math classes, you always say, oh, when did the two graphs cross? Okay, we could figure that out. It's fair to say that at some point in the future, like for example, if we go back to our calculator and we go to Window, and we go to X max and we go out 40 years instead of 20, and we go to Y max, let's make that number a little bigger. Let's try, I don't know, just 200,000 for now. I don't think I'll need that. Okay, hit enter. Okay, and you press graph. You'll see here is salary, and here comes healthcare. All right, so 40 years into the future, look at what we have. All right. So you can clearly see, here we are. This is at 40 years. So this is the year 2040, which you might think is far away, but it really isn't. You know, we're talking about, what, 17 years from now. This is unsustainable. I mean, in terms of a total height, compare that height there to this height there, and you can see that this green line is way more than half of the red line. It's almost 80%, I bet, 80% of income on healthcare. So that's clearly not sustainable. But my claim is, and I think this is, most people would agree, that it would be long before that people started to say, I just can't afford this anymore. Okay? Probably in this case scenario, we're talking about the year 2020, having a 40% of your salary go towards the cost of health care. Okay? And you also have to keep in mind, our formula for health care cost was 7737, right? Times 1.07 to the x was the best case scenario based on the last 10 years of data, right? So this seems very grim. What's a way to combat this? What's something that maybe households can do to sort of fix this problem a little bit? So one thing that is possible, it is possible that if you have a household where you have two adults that maybe can work, which is a possibility. Not all households have that luxury, but if you did, then we could take our salaries and double it. So let's see what happens in that case. Okay, so we'll go back to y equals. I'm going to take this 3907 and double it. That would be 7814, right? 78014. Okay, so it's going to shift let's make our graph start at a much higher point. We're still going to go, I'm going to set it for like, say, 30 years into the future. We're still going to have a Y max of 200,000. And let's press graph and look at that picture. So here's salary for a household with two people bringing income home compared to healthcare costs for that family. All right, it doesn't look as bad, especially at the beginning. So let's take a look at that, see what we can say, right? All right, so let's see. So here we go. Over here is the point 2, 7737. And over here is the point, oh, not 2, I'm sorry, that's 0. And over here is the point 0, 78014. So let's compute that ratio again. Percent income on healthcare would be 7737 divided by 78014. That's going to be a little bit more reasonable. What are you getting? So maybe about, let's just say this is about 10% to be safe. That's going to be a little less than 10%. All right, that's probably not a number that's going to make people very uncomfortable. Okay, but by having two adults in a house work, does that just prolong the time until the problem occurs? Let's go out here now and see what we have. Now we knew this is the point, well, this is actually 30 years into the future. So this is 30 comma something versus this one is 30 comma something. So let's go figure out what those somethings are. So press this. We're going to hit the trace button. We'll type 30 enter. And the salary of that family after 30 years should be about 206,624. 206,624. Okay? And let's go back and check out healthcare. Hit the down arrow. And after 30 years, we're looking at 58,896. 58,896. All right, so let's do that again. We're going to go percent income on healthcare is going to be 58,896 over 206,624, which gives us about, looks like about 29%. So here we are. We're getting close to that number again. 29% of our salary is going to be spent on healthcare costs. Again, you have a job where an employer might be paying a portion of that. Okay, so be it. But you have to remember, even if your employer was paying health insurance for you, that means probably your salary is going to be a little bit less than it could have been, right? Healthcare goes to hire you. If an employer goes to hire you, and they're like, okay, I want to offer you a salary of $70,000, or let's think of it this way, actually. Pretend the employer has $70,000 to spend on an employee. You got to subtract $20,000 out of it right away to pay for healthcare if that person wants it. So that means your salary really can only be $50,000. Okay. Now you are getting a healthcare benefit, which is a huge benefit and something that we should be happy to have. And I'm simplifying the problem a little bit here. But you have to realize that there's a cost for everyone. The employer, the employee, right? All of us are sort of fitting the bill for this.